Hey, so just want to give you a quick little run through on the lab. So the lab is on our Weebly right now. It's all up there, including all the simulation. It's right directly on our Weebly. You don't have to go to the FET site. You just go there and play with it. You click on there's three dots in the bottom right hand corner. You make it full screen if you're free. But the whole idea here is we're going to want to look at now at a pendulum. And a pendulum is a great example of what we call a simple harmonic oscillator. And those things produce waves. And we want to be able to produce waves and look at the relationship between some of the variables involved in waves. So we're going to now look at what relationships. We're going to look at the relationship between a pendulum's frequency and its amplitude, the mass that's swinging back and forth, it's called the bob, and the length of the string. Okay, so we're going to try to see if we can find a relationship between them, if there are any relationship between these. But first thing I want to do, before you do anything, I want you to come up with your own theoretical explanation here. So I want you to go to the lab sheet and fill in the three little questions here. So what do you think and why? So why? So do you think the amplitude, as we increase the amplitude, the amount that the pendulum swinging back and forth, does that change the frequency? Does it increase? Does it increase the amplitude? Well, compared to a little wobbling back and forth to a big wobbling back and forth, will the frequency increase, and why? And also, if I increase the mass, will that change the frequency? And if I shorten the string, will that change the frequency? So before you move on, stop right now, answer those three questions, okay? Because there are some spoilers as we go along. So right now, before you do anything, it's important for the lab. You stop right now and go through that, okay? Stop. That means you, Dalton, okay? All right, so hopefully you guys have got that done. What you're going to do is you're going to go to the simulation. It looks like this, and it allows you to move this pendulum back and forth, and it gives you a measurement of the angle. This is actually important because in the original way to do the lab, we talked about the amplitude. We were measuring 10, 20, 30 centimeters as an amplitude. We're going to use the degrees here instead. And it allows you to control the length of the string and the mass. All right. Now what you're going to do is you're going to swing it, and using the stopwatch, you're going to count the time it takes for 20 cycles. Time it takes for the pendulum to go back and forth 20 times. Now be careful here. That means a full cycle. So if you're measuring from this extension, the full cycle is going all the way to the one side and all the way back. Okay. Or if you're going to use the middle, it's going to have to go through twice. Okay. So be careful that you're measuring the actual full cycles. We're going to measure 20 cycles, and then from there we're going to calculate the frequency. So first thing we're going to do is we're going to fill out the charts. Charts look like this, and you're going to calculate the time, measure the time it takes for 20 cycles. Now here it says in the amplitude 10, 20, 30 centimeters. We're going to change that to 10, 20, 30 degrees, which you can actually measure on our little protractor up here, and it shows us the angle that. Okay. Then you're going to put in your times that it takes for 20 cycles. Then we're going to calculate the frequency by being just 20 divided by the time it takes for 20 cycles. Okay, because remember that frequency is the number of cycles in 1 second, and this t20 represents the time in seconds for 20 cycles. So 20 divided by that time will give us the frequency. Okay. Now, a couple modifications. First thing we're going to change is the centimeters we use for amplitude is going to change to degrees, and the masses, instead of 200, 150, 100, we're going to use 0.5 kilograms, 1 kilogram, or 0.5 kilograms. Right, just to make things easier using simulation that we have. Right, and then what I want you to do is I want you to make 5 graphs. So you're going to make a graph using Excel, of course. Okay, so you can make a graph relating frequency and amplitude. Okay, now frequency is what is going to be the dependent variable, so that'll go on the y-axis. Your amplitude will go on the x-axis. Frequency and mass, again, y versus x. Frequency and length, the frequency on the y-axis, length on the x-axis. And then you're going to calculate, make a graph of period versus length, and then period versus the square root of the length. Okay, I'd like this to be the don't use period squared. Use the square root of the length. So period versus root L. That's hideous. Okay, and then you're gonna have two more questions, which is three questions. Conclusions part E, which is evaluate your results, and F is a error calculation, and G is just a math problem. Okay, when I tell you these letters E, F, and G, they're all on the textbook sheet that's also on the Weebly. Now, quickly, the error calculation, little spoiler here, the period is actually related to the square root of the length, the string. So when we end up with this formula, we can't derive this formula. This formula requires a little bit of calculus, but the period is actually equal to 2 pi times the square root of L over G, which tells us that there is a linear relationship between period and root L. So you should end up with a graph that has this linear relationship, and we can calculate a slope. Right? We can get a slope of this graph, and that slope will be our experimental value. Right? That's going to be our experimental value. This 2 pi root G is our theoretical value, and from there we can get a error percentage, right? Percent error, just like we usually calculate. All right. So that's all that I'm asking you to do for this graph. Let's go back to here. So you're gonna have if you look on the sheet, there's more. So you're gonna get a procedure, an introduction, hypothesis that you've already done. You've already done the hypothesis before you listen to this, right? Right. Then you're gonna have your procedure. Now procedure is gonna be a little bit more complicated because maybe talk about what you did in terms of on the computer. Okay. So using the PhET simulation and what values you use, but don't use the procedure that we use textbook that I've given you using this simulated version. Then you're gonna have 5 graphs. Then you're gonna talk about your relationships. Then you're gonna look at your error. Then G that's a math question. All right. Okay. So I hope that helps, and have fun. Okay. Now it's important that you do this lab before you move on to lesson 6, which is resonance. It's very important that we figure out some of these relationships between frequency before we start looking at it. Okay, it's quite important. All right, so have fun and stay safe, and I'll be talking to you later.